Good afternoon, class. My name is Dr. Araipo, and here's module 1 of Algebra practice test, which covers chapters 1, 2, and 3. Chapter 1, equations. Chapter 2, graphs and linear equations in two variables. Chapter 3, inequalities. Let's start with the first equation. 4 minus the parentheses 3x minus 8 equals x. To solve that, we are going to distribute the negative sign. We get minus 3x plus 8. 4 and 8, they add up to 12. Negative 3x moves, becomes 4x. Divide by 4, and the answer is 3. We distribute again. 3x minus 15 equals x, plus 8x minus 4. 8x and x, they add up to 9x. We can move the 3x, make it negative 3x, and move the negative 4, make it positive 4. We end up with negative 11x equals 6x. Division by 6 gives us the final answer. To solve this, it's very simple. All you have to do, move things around. In this case, you can just move negative 17.9 and make it positive 17.9 on the other side. You don't even have to write it here. This goes to 0 because you're adding 17.9 to both sides, and y becomes 9.6. You can deal with it just the way it is, or you can multiply both sides by appropriate powers of 10. In this case is simply number 10. And if you do that, this changes to 15x minus 24 equals 39 minus 12x. Now we can move the negative 12x, becomes positive 12x, with 15x is 27x. We move the negative 24, becomes positive 24, and 39 is 63. In other words, like so. Divide by 27, 63 over 27, drop the common factor of 9. Remember, when you're dealing with a fraction, you always have to put it in its lowest term if you can. What happens when we are dealing with fractions, there are different ways of approaching it. In this case, because one side has 3/4 of an x, all you have to do, multiply by the reciprocal of 3/4, which is 4/3. As you can see, the product of these two is 1, so the left side is x. 15 divided by 3, 5 times 4 is 20. We can do the same thing here. We can multiply both sides by the reciprocal of this number, which is 5/4. And therefore, the left side, this becomes 1. We end up with 6x plus 1. 8 divided by 4. Remember, this is 8 over 1. If you want, you can even write it 8 over 1. And 4 and 8 cancel each other. You get 2 times 5, which is 10. Subtract 1. 9 over 6 is the answer, which simplifies to 3/2. 3/2. For a case such as part C, it's a good practice to multiply by LCD to clear out all the fractions. There are 1, 2, 3 fractions, and their LCD is 40. So if we multiply by 40, let's see what happens. For the first one, 40 divided by 8 is 5 times 3 gives us 15x. 40 divided by 5, because this is the same as 40 over 1, by the way. If you want, you can write it as 40 over 1 and deal with it that way. 40 divided by 5, 8 times 4 is 32. 40 divided by 5 is 8 times -1 is -8. So we get 15x plus 32 equals -8. 32 moves to the other side, becomes -32. So we have -40. Therefore, x becomes -40 divided by 15. And as you know, there's a common factor of 5, and we must reduce that. Now, this question was simple enough that we could have just moved this. And I hope you realize this is -4/5 on the other side with -1/5, that becomes 1. So if you move this, to the other side, it results in this. And all you have to do, multiply both sides by 8/3. Multiply both sides by 8/3, you have the answer. The next question is asking to solve an absolute value equation. So what are the steps involved? Number one, isolate the absolute value. So if this is isolated, you can move on. So what is your next step? If it's isolated and on the right side you have a negative value, the answer, there is no solution. The answer is there is no solution. If it's positive, then you can set this 4x minus 7 equals 5 and equals -5. There are two equations you are going to solve, these two separate equations. And of course, when you're done, you're going to check. We need to isolate this. It is already done for us. So since this is positive, 4x minus 7 is plus -5. We move the -7, we get +7 on the right. And we can divide both sides by 4. And now, because we can combine them, we must. 7 minus 5 is 2/4, which is 1/2. 7 plus 5, 12/4, which is 3. And you must check. So I'm going to check one of them. For example, if I want to check this one, I have the absolute value of 4x. That means 4 times 1/2 minus 7. And I'm checking to see if I get the answer on the right, which is 5. 4 times 1/2 is 2. Two minus 7 is -5, and absolute value of -5 is +5, and it checks. You have to check the second number as well. The process of solving this one is ultimately the same. Once you drop the absolute value and solve the other one, you drop the absolute value and you put a negative sign in front of one side. It doesn't matter which one. So this is one of them you're going to solve. This is another one. So you drop the absolute value from both sides. That's one equation. The other one, you drop it and you put a negative sign in front of one of them. It makes no difference which one. So if I put the 2x on this side, x minus 2x becomes minus x. -5 goes to the other side with 3 gives us 8. they give us negative x. And x becomes negative 8. For the bottom one, we are going to distribute the negative. And now we're going to move things around. If I move the negative 2x with x becomes 3x, negative 5 with negative 3, negative 5 changes to positive 5. So let me write this for you. So negative 2x becomes positive 2x. Negative 5 is positive 5. There you have it. X becomes 2/3. And I'm going to leave it for you to check. This must be checked, class. Make sure to check your work. This is a general question, and that's the idea behind isolation. Take a look. The first step is isolation, which means you don't want to touch the absolute value unless this number 1 is gone, which means you are going to subtract it from both sides. And now that it's gone, you can move on and say 2x minus 5 is plus minus 2. Move the negative 5, make it positive 5. Divide both sides by 2. Now 5 minus 2 is 3/2. 5 plus 2 is 7/2. They both must be checked. Now, if any of these end up with a negative, for example, if this number is negative, there is no solution. Or if this number were negative, there is no solution. Because absolute value in the worst case can be 0. Because it's distance from 0. It can't be negative. We want to solve for x. That means there are 2 ways you can move this and then multiply by 4/3. Or you can get rid of the fractions. Clearing out the fraction means figure out the LCD, which is 12, and multiply both sides by 12. Now, if I multiply this one by 12, get 12 divided, in other words, 12, you can write it 12 over 1. 12 divided by 6, 2 times 5 gives me 10. So this is 10y. 12 divided by 4 is 3 times 3, 9x. And the right side is simply 48. So in one shot, we clear out all fractions. Again, this gets multiplied by the first, by the second term, and the right side. We are solving for x. Move the 10y. Becomes negative 10y. Divide both sides by 9. And that's your final answer. We want to solve for p. Let's first and foremost clear out this denominator by multiplying both sides by 4, which results in 4w equals 4b plus 3 pw. Since we are solving for p, we want to isolate the p. Therefore, we move the 4b. And now we want the p, we divide by 3w, and that's our final answer. So divide both sides by 3w. I can write it here. On the other hand, if we want to solve for w, so right here, we're going to move from here since it's been done already. We want to solve for w, we bring all the w's together. So I can move this one to the left side. And now I can factor out the w. Now w is completely isolated. Let's get rid of the parentheses. How? Divide by it. And that's the answer for w. This was the answer for p. John leaves his house at 7 a.m. His sister Mary at 8:30 and tries to catch up with John. She's walking 2 kilometers per hour faster than him on the same route in the same direction. If they both kept on the same route, Mary could reach John in 3 hours after she left. We want to find their speed. This is a class of problem known as motion problem, which means D equals RT. So I want you to pay attention to, this is, okay, person of interest. This is the table you need. D equals RT, just fill them up. For John and Mary, we are looking to find their speed. We don't have it, but we know she is going faster. So if John is going by X amount, Mary is doing the same plus 2. So this is X plus 2. Now, the time it takes Mary to catch up in 3 hours. So the time that Mary has been walking, traveling is 3 hours, but John left at 7 a.m. Whereas Mary left at 8:30, the difference of 1.5 hours. So 3 plus 1.5 or 1.5 would be the timing for John. And they cover the same distance. So X times 4.5 is the same as X plus 2 times 3. That's the idea of D equals RT. Multiply these two columns. And now set them equal and you're done. Now, of course, you're going to distribute, you get 3x plus 6. You're going to subtract the 3x. You get 1.5x. And you divide by 1.5, we get 4. This is John's speed. Mary's speed is the same thing plus 2. And it's always a good practice to write the units. So 4 kilometers per hour, the speed for John, and X plus 2, 6 kilometers per hour for Mary. Here's another motion problem. A train and a car leave from the same railroad station at the same time, headed for the same destination. The car is doing 50 miles per hour, while the train is doing 70 miles per hour. If the train arrives 2 hours ahead of the car, find the distance between the 2 points. Again, let's plug in, obviously, 50 and 70. 50 is the speed of the car, train is 70. Needless to say, you realize if the train is going fast, it's going to get there faster. And so if it takes X amount for the train to get there, and it's going to get there 2 hours ahead, that means this is 2 hours behind, X plus 2. Just to make sure everybody understands what's happening, if you choose X for the car, as far as the time, this becomes X minus 2. And the distance they cover, this is 50 times X plus 2, this is 70 times X, and they are identical. And pay attention to the units, the rate, miles per hour. This is the time in hours. And this is the distance in miles. So we have the units. That's important. And now the two distances must be identical when you set them equal. 50 times X is 50X, 50 times 2 is 100. Subtract 50X, you get 20X. And divide by 20X is 5 hours. Let's go back to the question. Did we answer the question? If the train arrives 2 hours ahead of the car, find the distance between the 2 points. This is 5 hours. We didn't answer the question yet. So if X is 5, by the way, X plus 2 is 7 hours. What is the distance? 5 times 70 is 350, or 7 times 50, 350 miles. You really should check it by looking at both cases, just to be on the safe side.
I have a question.
Sure.
So just to clarify, I really like that when you got the hours, you noticed or you stated that we didn't answer the question fully because it says find the distance versus the time. And I was wondering for the distance, would it be like, would we just, I mean, not for this, or yeah, for the distance, would we just plug in the x back into the original equation and then solve for that, and that's our distance? Is that how you have?
Exactly. You
Okay,
can put it into this equation and this. In fact, put it in both equations, and
okay,
they should give you the same answer. That shows that we haven't made a mistake.
okay,
This is
for
check.
sure. Thank
My
you so
pleasure.
much.
My pleasure. A chemistry lab wants to prepare 10 liters of 48% acid solution. In stock, we have 80% and 40% acid solutions. How many liters of each we should mix to end up with a 10-liter mixture? So this is a class of problem known as mixture problem class. In the mixture problem, when we mix two things, we add up their volumes or their weights, and they are constant. So take a look at what happens. We have a 80% solution. We have a 40% solution. You can write it as a percent or 0.8, 40% or 0.4. But we want to mix these two to get a 48% solution or 0.48. How much of it do we need? We need 10 liters. So this is what we end up with. How much of the 80% solution do we need? We have no idea. How about X? How much of the 40%? In this case, because we know the total is 10, and that's the idea behind the mixture problem, the total volume is not going to change. It's constant. So this must be 10 minus X, meaning if X ends up being, I don't know, 7, then this must be 10 minus that, which is 3. The total volume is 10 liters. Now, pure or actual amount of acid. If something is 80% acid, that means the rest of it is not. So only 0.8 times X is pure acid. This one is 0.4 times 10 minus X, that's the pure acid. And this is 0.48 times 10. And this is a mixture problem. The total number, the total amount of acid, which is the sum of these two, is fixed. It's equal to the last one. So the first one plus the second one gives us the third one. And that's the equation. Again, when you're looking at the question versus the table is the translation of what we just did, which results in this simple equation. So question, table is the translation, equation, we are almost there. We distribute the 0.4, that becomes 4, that becomes minus 0.4x, and we combine terms as follows. This one and this one we combine, we get 0.4x, and this one we subtract from the right side, we get 0.8. When we divide both sides by 0.4, we get x equals 2. So what is x? 2 liters of 80% solution. How much is left? 10 minus 2, or 8 liters of 40% solution. Here's another mixture problem. How many liters of a solution that contains 15% chemicals must be mixed with 6 liters of solution containing 10% chemicals to make a solution containing 12% chemicals? So why don't we make up the same type of table? So we have a 15% solution, 10% or 0.1, and the mixture must be 12%. One thing I want to emphasize, this number will always be between these two, otherwise we've made a mistake. The mixture must be between the two, can't be larger than the largest one, can't be smaller than the smallest one, so must be somewhere in between. And so which one is given? Well, we know the 10%, we have 6 liters of that. But what about the 0.15 or 15%? We don't know how much we need. So how about X? So if that is X, then this is a mixture problem. So the total volume is constant. The total volume is the sum of these two, which becomes X plus 6. Now the pure amount, just like the previous page, the product of this column and this column is the pure amount of acid. So 0.15x, 0.1 times 6, 0.12 times x plus 6. And these two add up to give us the last one. So again, as you can see, question, translation through this table, resulting in this equation. We are practically done. This is 0.15x, 0.6. When you multiply these two, 0.12x. When you multiply these two is 0.72. We are going to move things around. We're going to subtract 0.12x. We're going to subtract 0.6, and we end up with 0.03x equals 0.12 division by 0.03 results in x being 4. So we need 4 liters of 15% solution to get the result we are looking for. So 4 liters of 15% solution. 4 liters of 15% solution. Admission tickets to the Braden River Little League All-Star Game cost $4 for adults, $1.50 for children. We have a total of 225 tickets with a total amount of $500 that was collected. How many adult tickets and how many children's tickets were sold? Again, it may not look like it. This is a mixture problem in essence. So you have to make up a table. Adults, the cost of ticket is $4. Children is $1.50. We know the total number of people is 225 because the total number of tickets is 225. We know that we collected a total of $500. So you translate this question into this table. So you don't know how many of each you have. You let X represent one of them. It doesn't matter. X is the number of children, then adults would be 225 minus X. If X represents the number of adults, the number of children would be 225 minus X. It doesn't make any difference. Now, how much money do we make from the adults? 4 times 225 minus X. Children, 1.5 times X. And how much money do we have? Total of 500. So these two add up to give us 500. So again, question, translation into this table, finally, this equation. Now, 1.5x plus 4 times 225, which is 900, plus 4 times minus x is minus 4x equals 500. Now, 1.5x and negative 4x, they add up to negative 2.5x. Subtract the 900 and you get negative 400. Divide by negative 2.5. By the way, you can write it as 4,000 over 25. And then 100 divided by 25 becomes 4 times 4 is 160. X is 160. If X is 160, the number of children or the tickets for children the number of tickets for adults is 225 minus that, which means there were 65 adults.